Hey everybody, today we are going to be looking at lesson 2-3. This is on square roots and cube roots. We've done a lot of the squaring a number before today, so hopefully this will be just a little bit of a review for you, and the new stuff will be cubes and cube roots. First of all, we know that squaring a number is raising that number to a power of 2. When a negative value is squared, be careful to note whether or not the negative sign is inside the parentheses. If it's inside the parentheses, what you're doing is you're taking that negative 2 times a negative 2. So you will get a positive 4. The one below it would be negative 3 times negative 3. You will get a positive 9. And then the last one, negative 4 times negative 4, will give you a positive 16. Remember from an earlier lesson that if the parentheses are not there, it is only the 2 that is being squared. So you would have that negative sign, then 2 times 2. So basically what you have is a negative 4. Same thing happens when you have negative 3 raised to the second power without the parentheses. That would be a negative 9. And then the last one would be a negative 16. So remember, if the parentheses are not there, it's not including the negative sign to be multiplied twice. Squaring a number is the inverse, also known as the opposite of squaring, of taking the square root. Again, we've had this in some previous notes. Taking the square root of a number technically gives you two solutions. For example, the square root of 16 can be either 4 or it can be a negative 4. Because if I take 4 squared, that will give me 16. And if I include the parentheses and the negative sign inside the parentheses, negative 4 squared also gives me a positive 16. But for most of what we're going to be doing, we're going to be looking at only the positive, okay, which is our principal square root. So when you're using the square root sign, the solution that we're looking for is the positive square root. Okay. Cubing a number, this is our new rule or new notes. We haven't had this one before. Cubing a number means raising something to the power of 3. Okay. It is the inverse of taking the cube root. So if I have the cubed root of 8, that answer is 2. Because 2 times 2 times 2 is 8. Think about it. If I look up here, 2 times 2 is 4, and 4 times 2 gives me 8. So, can a cubed root ever have a negative solution? Explain why or why not. So, could I take the cubed root of negative 8 and get or could I take the cubed root of 8 and get a negative 2? That answer is going to be no. Okay, because you can never have a positive answer. A negative number multiplied by itself 3 times will always be negative. So if I had negative 2 times negative 2 times negative 2, that is going to give me a negative 8. There's no way I can get that positive 8 because negative 2 times negative 2 is a positive 4 times negative 2 would give me a negative 8. Pause it right there so you can finish writing that out. Okay. All right, we're going to complete these tables at the bottom, and I'm going to expect that you're going to have to go back and forth and look at the first 10 perfect squares and first 10 perfect cubes. The first 10 perfect squares, you have these in previous notes. You know these already. 1 times 1 is 1, 2 times 2 is 4, 3 squared is 9, etc. So I'm just going to go ahead and complete this table. Again, you know these, or you should. Okay, but the ones down at the bottom, I'm going to be honest with you, I know up to 6 cubed, and after that I have to work it out. But 1 times 1 times 1 is 1. We have looked up the examples above, and we know that 2 to the third power is 8. 3 times 3 times 3 is 27. The next one is 64. 5 times 5 times 5 is 125. 6 cubed is 216. And again, what I said, oh, let me make that a little clearer for you. 216. 7 times 7 times 7, I'd have to work that one out. That's going to be 343. 8 to the third power is 512. 9 to the third power is 729. And 10 to the third power is 1,000. Again, pause the video if I wrote too quickly, because you will need these numbers. You'll need to come back to them and reference them. And then meet me on the back side. Okay, so for number 1, we're going to evaluate the following square roots and squares. So the first thing that I need to do, and again, hopefully this is all review for you. We have negative 4 to the second power. Notice the parentheses are there, so we are taking the negative 4 times the negative 4. That will give us a positive 16. For number 2, we have 2/5 in parentheses, and it's squared. So that means we're looking at 2 squared over 5 squared. That's what that means. And 2 squared is 4, 5 squared is 25. Number 3, we have negative 6 to the second power. There are no parentheses there. So that's negative times, basically, times 6 times 6. That will give us a negative 36. If the negative sign's not there, it is not correct. Number 4 is a perfect square. The square root of 144 is 12. But what is unique about this problem, we have that little negative sign. So make sure that you bring down the negative sign for your answer. Okay, the square root of 0.49. Okay, we know that the square root of 49 is 7, so the square root of 0.49 would be 0.7, or 0.7. Number 6. We have the entire fraction in a square root, so basically what that means is the square root of 4 over the square root of 9. Okay, the square root of 4, 2. The square root of 9, 3. So your answer is 2/3. Okay, I went through that kind of quickly because, again, you've done that in a previous lesson. But with the cubed roots, you might have to flip back and forth. Okay, so I've got the negative 5 raised to the third power, and it is in parentheses, but the parentheses don't really matter because we know that a negative times a negative times a negative is always going to give you a negative answer. So again, think of it this way: negative 5 times negative 5 times negative 5. Okay, I'm going to cheat and look back up at my answer. So I know that 5 to the third power is 125. Okay, so negative 5 to the third power would be a negative 125. Okay, 1/4 raised to the third power. Again, notice the parentheses are around the whole fraction. That would be 1 to the third power over 4 to the third power. Okay, well, you know that 1 times 1 times 1 is equal to 1. And 4 to the third power, 4 times 4 is 16, times another 4 will give us 64. Number 9, we have negative 10 raised to the third power. So negative 10 times negative 10 times negative 10. If you have to flip back to the front page, you know that it's going to give you 1,000. And because we have a negative times a negative times a negative, our answer is also negative. Let's do the inverse. The inverse is going to be the cubed root. So the cubed root of 216, and again, you might have to look back on your previous page up here. So the cubed root of 216 right next to the other one we were looking at, it's going to be 6. Okay, so my answer is, oh, look at that. Our answer is 6. Okay. If I have to look up at the previous page, I'll do so. The square or the cubed root of 512 is 8, but because that negative sign is hanging out, that makes my answer negative 8. Okay. If the cubed root is over both fractions, that means both the numerator and the denominator are to the cubed root. So the cubed root of 1 is 1. The cubed root of 27 is 3. So your answer is 1/3. Okay, those are pretty straightforward, but of course we need some word problems in there. You have to figure out, are we dealing with a cubed root or are we dealing with a square root to answer these questions? So 13, it says a set of 121 chairs needs to be arranged in a square. There's a key word right there to tell us what to do for a school assembly. How many chairs should be lined up in each row? So basically what I'm looking at, I have a square, okay, and I have 121 chairs. I need to find out how much in each row. So square means to the second power, or in our case, a square root of 121. So the square root of 121 is equal to 11. So we need 11 chairs lined up in each row. Number 14, we have volume. Well, maybe what you can remember from volume last year is that on your reference sheet, do you remember when you did PAV 1, 2, 3? A is for area, second power. V is for volume, third power. Also, it tells us right here that that is to the third power. So we know that the volume is 729 cubic inches. So what we have to find is the length of one side of the cube. So I'm going to take the cubed root of 729. Again, I may have to look at that front page to see what it could be. And when I do, it is 9, and I'm looking for inches. So one side is 9 inches. Okay. That should make the homework pretty simple. There's only 10 questions on there, so take your time. Hopefully this helped, and I'll see you tomorrow.